Exercise 4.2, question 7. Universal set. We've got the elements 0, 1, 2, 3, blah 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 until 9. And in set A, we have the elements that are x where there's a condition 2x squared minus 7x plus 3 equals to 0. This is a quadratic equation. So for quadratic equations, how many answers do you think we can possibly have? 2. Will we definitely have 2 answers?
Yeah.
No. It could be one answer only, right? It could also be no answer at all, isn't it? Okay. What about set B? We have x again. This time x squared equals to 3x. Again, this is quadratic, so we can expect 2 values of x, up to 2 values of x. So in question A, express set A and B by listing the elements. Okay. In set A, we have 2x squared minus 7x plus 3 equals to 0. How do we find the values of x then? For this one? Which method do you want to use?
Calculator method.
What is the calculator method if you know how to calculate the method?
Step 3.
Okay, yeah, no, it's okay. You want to use your calculator, you can tell me what to write. Okay, bracket x minus 3. Then 2x minus 1 equals to 0. Do you all get this from the calculator? I mean, do you all know how to get this from the calculator? Or will you actually write this from the calculator? X minus 3, x minus half. Which one will you write if you are using a calculator? Red or blue? Okay. In this case, both are correct. However, if the question is like this, factorize this, then some people will give me the answer in red, some people will give me the answer in blue. Which one is correct, or are they the same? Red one is correct, or the blue one? Is it right or wrong? Red, yeah, we established that red will be correct. But the blue one, which some of you are trying to use your calculator to give you the answer for factorizing, is it correct or not? The blue one. It is wrong, why? Okay, let us expand the blue one. Let's see what we get. If I just use this, I expand it out. I get x squared minus 3 over 2x minus 3x plus 3 over 2. That gives me x squared minus 4.5, which is 9. Oh, did I make a mistake? Minus 4.5. Minus 9 over 2x plus 3 over 2. Yeah, I think something wrong, leh? Minus 6 minus x. Okay, give me a moment. This is not 3 over 2x. This is half x. Right? Then minus 3x. Okay. So now this is minus 7 over 2x. So do you see that this is not equal to this? Right? They're not equal, right? How different are they? By a product of multiplication of 2. Okay? So only when I multiply this by 2, then they'll be the same. So if you want to use your calculator, go ahead for solving. For solving, that is when you have ax squared plus bx plus c equals to 0. This one equals to 0. Yeah, you can work backwards, but when it comes to factorizing, you better be careful. So this tells us that x equals to 3 or half. Right? So in set A requires me to fulfill this requirement, which is 2x squared minus 7x plus 3 equals 0, meaning x is simply half or 3. Only these two. So to rewrite set A in terms of its elements, we've got half and 3. Oh, in the universal set, I've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Does half belong there? No, so I have to remove half. So this is the only answer. Must put reject? No need.
Bracket,
I mean, whether you put or not, it doesn't really matter lah, because this is my final answer. They ask you to list it down, and I list it down in terms of its elements, and this is my final answer. Okay, so now let's go on to part B. Oh no, we have to list the elements in set B as well. Now in set B, we do the same thing. We focus on this quadratic equation where we have x squared equals to 3x. Then I want to solve for it again, right? What's the value of x? How do we solve this? How to solve? Solve. Bring the 3x. What do you mean by bring the 3x over? Then what will you do?
substitute the x.
Substitute with what?
What did I do?
Okay, Junior, you say bring the 3x over, right? What do you mean by bring the 3x over?
X squared minus 3x.
Okay, you meant x squared minus 3x equals to 0. Subtract 3x on both sides. Then what do we do?
Take out the x.
Take out the x. You mean factorize the x out. Okay, x minus 3 equals to 0. Look, this is factorizing. To solve quadratic equations, you know 3 methods. One is by factorizing. The second one is completing square. And the third one is quadratic formula. Okay, so after we factorize, then we have x equals to 0 or x equals to 3. Can both of them be accepted? Is 0 one of the values? Yes. Okay, so B, set B, we've got 0 and 3. Okay, the reason why I point this out again is because I want to check, did anybody do this? Okay, from x squared equals to 3x, then you divide by x on both sides to get x equals to 3. Did anybody do this? Divide by x on both sides? Is there anything wrong with it? What is wrong with it? Huh? I divide by x, ma? Both sides are divided by x. What's wrong with it? What do you mean 3x is not x? Right? I've got the answer. X equals to 3. Yeah, I saw it over here also. What's the problem? So? Huh? So what's wrong with dividing by x on both sides? So? What you do on one side, you do on the other side, right? Then it will be equal, ma? Which is what I did. I divided by x on both sides. So what is wrong with this? 1 plus minus. Yeah, okay, that's the problem. Why only got one answer? Where's the other answer? What is supposed to be the other answer? 0, right? Where did it disappear to? Because I divided by x, then the 0 disappear, right? The answer for 0 disappears because I divided by x. Is there a problem? Why?
Can't just disappear.
Okay, it can't just disappear. In fact, x is equal to 0, right? When you divide by x on both sides, what are you dividing by? We say that x equals to 0. From here we see that, hey, this is one answer, x equals to 0. If you divide by x on both sides, what are you dividing by? 0. Can or cannot? Not lah. So don't do this. Refer to only one of these 3 methods. Either you factorize, which is what Junior did, or you complete a square, which nobody did because it doesn't make sense to waste so much effort, or you use the quadratic formula, which you also don't have to do it also. Okay? So now we've got the 2 sets A and B listed with their elements. So draw a Venn diagram to represent the sets. So our universal set. Then we've got A and B. I know that they have something in common, right? What is the value, the element that is common for A and B? 3. Okay. Does set A have anything else? Does set B have anything else? 0, right? So I must put it here lah. Then what else is missing? The rest of the numbers. So we got, just put them randomly, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay? So, alright with this question? Can we put A inside B? Actually we can. Actually this, my Venn diagram, yeah, actually this is not the correct Venn diagram. You are right.
So it's like correct. For A, I don't need
So A is actually inside B. A has the value 3, right? And B 0, like this. What I did also can. No, actually what I showed earlier on was not the correct answer. Because if you remember what I just drew earlier on, which I now say is wrong. I've got A over here, I've got B over here, right? Then 3 and 0. Then what's inside here? There's nothing, right? So if there's nothing, it must therefore mean that the entire set A is inside set B, right? So this is now the correct answer. Set A is inside set B. Now can you tell me the relationship between set A and set B? This is my question to you. What is the relationship? Okay, A is a proper subset of B. So proper subset has two requirements, right? First, it must be a subset. Is everything inside A inside B? Yes. Is A equal to B? Therefore, it is a proper subset. So when I ask for this question, my answer that I expect will be A is a proper subset of B. This is the answer. Okay? You will be tested on writing this. Writing down the relationship. Okay, so that's all for question 7. Which one do you want me to go through next? For 4.2, anything else? Or is everything okay? 4.2, next question, anybody? Yes, 8. Okay, question 8. All triangles. That's our universal set. P will be triangles with at least 2 equal sides. 2 equal sides, and Q equals to triangle with 3 equal sides. First, do you understand set Q? Do you understand what set Q means? It is a set of triangles that are equilateral. Excellent. So all that has 60 degrees. The 3 sides are the same. So it can be 2, 2, 2 cm, 3, 3 cm, 1.5, 1.5, 1.5 cm, so on and so forth. What about P? Isosceles triangles. Yes. Is that all? Can it be equilateral? Yes, right, because they say at least 2 equal sides, so I can have 3 equal sides. So set P will contain isosceles triangles as well as equilateral triangles. So now, without reading the rest of the question, can you tell me a relationship between set Q and set P? Which one is a proper subset of which one? So Q is a proper subset of P. Okay, excellent. And then all these are proper subsets of the universal set, right? Okay, so now we understand the question already. They said that triangle number 1. I think we have just answered part A already. Is Q a proper subset of P? Yes. Explain our answer. All equilateral triangles, that is the elements inside Q, are elements of set P. Okay, that is the first condition. Everything inside Q is found inside P. Next condition, we want to show that Q is not equal to P. I want to show that something inside Q, I want to show that these two sets are not the same. So we say that not all isosceles triangles in set P are equilateral triangles in set Q. So P is not equal to Q. Therefore, Q is a proper subset of P. Okay? Can? Uma, okay? So part B. Draw a Venn diagram again, represent the sets. Okay, so Venn diagram, my universal set. We say that Q is a proper subset of P, yeah? So this being P, then Q must be inside here. And now I have triangle 1 and triangle 2. Where does triangle 1 fall under? Is it inside Q? Is triangle 1 in set Q? Set P. Yeah, Q is inside P, so is it inside Q?
Yes. No.
So is triangle 1 inside Q?
No.
No, but it is inside P, right? So it must be found here lah. Triangle 1. Not inside Q, but it is inside P. Okay, where does triangle 2 lie? Outside P. Okay, triangle number 2. That's it. Can? Any more questions? Yeah? What? No questions. So 4.3 now? Okay? 4.3. Which question do you need help with? Sorry? Yes, any? None. So we can move on already. Shufi, any question? Okay, here we have the universal set is an integer between 1 to 13. So we've got 1, 2, 3, all the way until 12 and 13. That's my universal set. A. X is a prime number. List the elements of A now. Come on. Quickly, quickly. 1, 3, 5, 7, 9. No 9. Okay, 11, 13. All agree? No, Shufi, what is wrong? 1 is not a prime number. 1 is not a prime number. Anything else? What about 2? 2 is a prime number. These are the elements in set A. 2, 3, 5, 7, 11, 13. Okay? Now in set B, X is a factor of 12. Okay, what do we have in set B now? Can we start from the smallest? 1, 2, 3, 4, 6, 12. Okay, these are the elements in set B. So draw a Venn diagram. Set A and set B, do they have anything in common? Yes? Okay, so it should be like this, right? A and B. So now my approach, I try to list down everything that is common first. Okay? So I know the common numbers will go in the center, the intersection point. Which one is common? 2, 3. Any more? No, okay. What else is in set A? 5, 7, 11, 13. 5, 7, 11, 13. What? Is this okay? Then in set B, we've got 1, 4, 6, 12. 1, 4, 6, and 12. See the way I write it, you wouldn't be wondering whether I'm writing 57 or 1113, right? You must make them distinct. Okay, and what else is in my universal set? Okay, so I am expecting 13 numbers, right? From 1 to 13. So 1 is here already, 2, 3, 4, 5, 6, 7, 8, 9, 10, and that's it, right? Okay, 11, 12, 13. Yes, I've got everything in now. List the elements of A union B complement. That is in part B now. So we need to find out where exactly is A union B complement. That's where we need to do our working, and our working requires us to shade. Draw your A and your B. First, I shade A in one direction, entire of A. Now I need B complement. B complement is everything outside of B. So I shade the other direction. What? If you don't shade that, how do you know which region you require? If you can do it mentally, then good lah. Okay? So I cannot. I need to do this. So now I know A union B complement looks like this, and since it is a union means I take everything. It is not just intersection. I want everything that is shaded, which means my final Venn diagram looks like this. This is A, this is B, all of these. Okay, this is my A union B complement. Now we refer back to our Venn diagram. Which numbers, which elements fall inside my shaded region? Everything that is not 1, 6, 4, 12. Okay, so A union B complement equals to 5, 7, 11, 13, 2, 3, 8, 9, and 10. Is this answer from the back? Should be lah. Okay, so this is how we do part B. Now if we want to do the next part, C. A complement intersects B. So I need to do my working again. Okay, so A and B. I shade A complement. I want A complement intersect B. So A complement is outside A, yes. Goes into B. And now I require B as well. So use the other direction. And now it is a intersection. So intersection means I want all the little crosses. Where are all the little crosses? They are over here. Okay? So if I